Welcome back to Chapter 14, Part 8, Introduction to Inference. We're going to continue working with some examples of hypothesis testing. Now, looking at this problem, we have a simple random sample of 35. We know the population standard deviation. They give it to us as $13. And these withdrawals are known to have a normal distribution. So the assumptions of this chapter are met. So we can do a hypothesis test. We want to test that manager's claim at a 0.05 level of significance. And what is the claim? That the mean withdrawal from his machine is different than the amount the manufacturer says, which is 60. So we are now ready to begin our hypothesis test. Now, as I said, the assumptions of this chapter are met. So stating the null hypothesis and alternative hypothesis, it's the manufacturer says that the average ATM withdrawals is $60. The manufacturer of the ATMs, and the manager of the convenience store says he thinks it's different. So the alternative hypothesis is not equal to. So there's our null and our alternative hypothesis. Once we have that, knowing the population standard deviation is $13, it's a simple random sample and that our population is normal, we now know what the null hypothesis distribution is. It's a sampling distribution of sample size 35, it's got a null hypothesis mean of 60, and the standard error of 13 divided by the square root of 35. So step number 2 is to state the level of significance. Well, that was given to us in the problem as 0.05. The next step is to calculate the test statistic. Now remember what the test statistic is. It's how many standard deviations our sample mean is in the null hypothesis distribution. So we are going to say x bar, which was 55 in our sample, minus the 60, because that's the mean in our null hypothesis distribution, divided by our standard deviation, population standard deviation, divided by the square root of n. That's our standard error. So that's going to be 13 divided by the square root of 35, giving us a test statistic of negative 2.28. Now we're ready for step 4. We're going to calculate the p-value. And remember, for the p-value for a two-tailed test, you have to do twice the probability, and since our test statistic was negative, twice the probability that z is less than negative 2.28. So our p-value is 2 times 0.0113, which is 0.0226. So the p-value that corresponds to our test statistic of negative 2.28 is 0.0226 for this two-tailed test. So now we have to determine whether we're going to reject or not reject the null hypothesis. So I write down the p-value, which we just calculated as 0.0226, and our significance level, which is 0.05. What's the sign that should go in between those two? What's the less than sign? Because 0.0226 is less than 0.05. So that means our p-value is less than alpha. And remember, last time I told you, if the p-value is less than alpha, we will reject the null hypothesis. So we are now ready to state our conclusion. At a 0.05 significance level, there is sufficient evidence to support the claim the manager of the convenience store made with an ATM machine, that the mean withdrawal from his machine is different than $60. So when we reject, there is sufficient evidence to support the claim. Now, let's see if the problem was changed just a little bit. Suppose that we do the same problem, but this time we make our alpha equal to 0.01. Well, steps 1 through 4 would be the same. So let's look at them. Except for step 2 would say alpha being 0.01. But everything else would look almost identical. Now, once we get to step 5, this is where things will change. So step 5 would be we put our p-value, which was 0.0226, and our new alpha of 0.01, and what sign would go between those? The greater than sign, because 0.0226 is larger than 0.01, so our p-value is larger than alpha. Then we do not reject the null hypothesis. So the way we would interpret that would look almost exactly like the interpretation we made at a 0.05 significance level. But instead of saying sufficient, we're going to say insufficient. Because at a 0.01 significance level, there is insufficient evidence to support the alternative hypothesis, or the claim of the alternative hypothesis, which is the claim the manager of the convenience store with the ATM machine made that the mean withdrawal from his machine is different than $60. So if you do not reject the null hypothesis, you have insufficient evidence to go with the alternative hypothesis. So you have insufficient evidence to support that claim. But if your p-value is less than alpha, then you would reject the null hypothesis, and that would be we have sufficient evidence to support the claim of our alternative hypothesis. So again, if we reject H0, there's sufficient evidence to support our alternative hypothesis. If we do not reject H0, there's insufficient evidence to support our null hypothesis. Our alternative, it's insufficient evidence to support our alternative hypothesis. Now that's how you would do it by hand. Well, MINITAB also has a way in which for us to do this very same problem. So let's see how we would solve this problem in MINITAB. This is the general MINITAB commands that you would use. You'd say 1Z, then you'd put in your sample size and your sample mean. Then you put a semicolon because you're doing subcommands, because you have to tell MINITAB a couple of things before it completes doing this hypothesis test. Then you're going to say sigma. You're going to actually write in sigma and give the population standard deviation, semicolon, and then test. What you're going to do is you're going to put the null hypothesis value. Then you're going to do a semicolon, and then the alternative. If it's alternative, you write the word alternative, or the first four letters. And if it's a left-tailed test, you would put -1. If it's a right-tailed test, you put +1. And if it's a two-tailed test, you put 0 in for W. So let's see the problem that we just did. We had an N of 35. We had an X bar of 55. We had our null hypothesis value was 60, and the alternative, because it was a two-tailed test, would be 0. So we're going to do, right in here, the prompt, we're going to say 1Z, and give the N, which was 35, and my sample mean, which was 55, semicolon. Then I have to let it know what the sigma was, what my population standard deviation that was given to us in the problem, which was $13. Now I have to tell what my null alternatives hypothesis, the null hypothesis mean is. So I say we're testing over mu0, which was 60. And now what was the alternative? Well, it was a two-tailed test, so we'd put 0 for the alternative and hit enter. They give us a p-value of 0.023. which, remember, is what we calculate for a p-value by hand. Now, the p-value that we do by hand won't be as accurate as MINITAB, but this time we came very close. In fact, right on the money. So our p-value of 0.023. So for this two-tailed test, I would say, is my p-value less than alpha? Well, if my significance level was 0.05, yes, I would say my p-value was less than alpha, and I would reject the null hypothesis in favor of the alternative. So I would say there is sufficient evidence to support the alternative's claim. So obviously MINITAB would give us the same answer. Now if we have data, the only thing that would change here is that we would say 1Z and let it know the data is in whatever column, C1, C2, whatever. But sigma, you'd still have to give what the population standard deviation is, what the null hypothesis distribution mean is, the mu0, and then which alternative. So it's almost the same exact thing, except for MINITAB will look at your data and determine the sample mean and, of course, know the sample size. And that concludes Chapter 10.